from Idaho. I strive to provide interesting videos about motorcycles, fabrication, welding, electronics, machining, and general creativity. I hope you enjoy. Hello from Idaho. Today we're going to talk about making a cooler for a TIG torch. TIG torches that have a lot of amperage going through them get quite hot, too hot to hold. And so the solution is to water cool them. And for that you need a water cooler that pumps cool water through the hose up to the TIG torch and back to the reservoir. I just bought a commercial grade welder, and it came with a water cooled TIG torch. So I decided to make a cooler. Isn't it a magnificent beast? I sold my two other welders and put a little extra cash with it and got this guy. 250 amps MIG, 200 amps TIG. It also stick welds, does spool gun, and it's a water-cooled TIG. I still have to make a water cooler. Anyway, I haven't turned it on yet, but it's got a very simple control system and very nice plug-ins. Here's all the accoutrements. So we've got a wired TIG foot pedal. More on that later. I'm working on a wireless design. And there's the stick welding stinger. There's the MIG welding stinger. And this is TIG welding with more gas cups and then a ground. It fits on my cart pretty well. It's bigger than the welder it replaces. I want to make a commercial grade cooler. The one that is sold for my welder is $585 plus $115 shipping. And so there's got to be a better way. They're a relatively simple device. As usual, I've created a full set of plans so that I can just sit down and make it. I like to make a kit, so just accumulate all the stuff I need, and then when I have it all, I just go for it. So I bought this PC case. This case is made for gaming PCs. It has lots of air intake on the top, on the sides, on the bottom. It has this nice glass door, which is going to be pretty handy for looking in to see that the cooler is working correctly. I had a lot of stuff on hand. Before I turned on the video, I took out a bulkhead and a shelf and a little door so that the inside of the case is completely vacant. I'm shooting for about $100. I had to buy a few things. The case I got off of Facebook Marketplace for $20. Here's my coolant reservoir, 2 gallons. It's going to fit inside very nicely, and it comes with a spigot. Not that I need a spigot. It comes with a little spigot, but I'm not going to use a spigot. I'm going to put bulkhead fittings into the spigot hole for supply and up here for return. And I had to buy those. The only real secret to this is it fits my enclosure and has a big lid, so I can get my hand in there to put the barricade fittings in, the bulkhead fittings in. I also bought a pump. This is a diaphragm pump, 1.2 gallons per hour. 5 amps at stall, basically. It doesn't use 5 amps when it's running, and for normal flow. The way these pumps are tested is they test for flow at no load. In other words, the output is just short. It just basically pumps water without a bunch of tubing or anything. And so given that, it's about 1.2 gallons. The other spec is the 50 psi spec, and that's if you clamp off the outfeed and there's no flow at all, then it'll get up to 50 psi, and in this case it'll shut off. This has got a little shut off switch in it. But anyway, that's how they're rated. We'll talk a little bit more about how coolers are made in general. Usually they have a bypass that goes from the output back into the tank in case your lines get clogged or whatever, but having a shut-off switch that prevents the pressure from ever going above 50 psi is a better deal than that. I also bought a small radiator. This mounts up 2 fans, which I dug out of my stores. Basically, one goes here and one goes there, and it's made for a gaming PC, so it's going to fit well. It's all brass inside. One of the things I should note, right, is that don't mix metals in your cooler. The TIG Torch has already got brass in it, and so make sure that all your other fittings and the radiator are either plastic, there's no metal in this, or brass. And that way you've got one kind of metal. There's no issues with galvanic corrosion or any of those kind of things. So there's my little radiator. It'll go in the back. I also bought some coolant made specifically for TIG coolers. You don't want to use coolant for a car or whatever. And then the other thing I ordered from Everlast is these 2 quick disconnects. They'll go on the front, and that's where the torch will plug in. These are actually the same as are already on the machine, and so I ordered those up. I obviously didn't have those things on hand. The stuff that I had on hand that I'm going to need is hoses, a power cord. The welder has an outlet in the back that turns on the cooler whenever the welder is on. And in order to do that, you need to plug into the back of the cooler and then provide power to this. Now, when this welder is running on 220, it provides 220 volts out this cord. When the welder is running on 110, it puts 110 volts out this cord. So you need a switchable power supply. I happen to have this one on hand. It's got way more than enough current. The total draw of this system is going to be about 6 amps or something like that, and this one has nearly twice that capability. And it has a little switch on the side that lets me set it for 110 and 220. So depending on what I got the welder in, I'll be able to set this correctly. I had that on hand. I've got fans, obviously. I only need 2. And then I've got a whole bunch of stuff that's just ancillary stuff. I got fittings and LEDs and hose barb fittings. I've got a big switch. All my wiring stuff, I'm beginning to take a clue from the Europeans. I'm going to break the line and the neutral on all my designs from now on. And so, let's see, what else have I got in here? Oh yeah, this is something that I had to order. This radiator takes type of fitting that is not that common except in certain PC gaming things. It's called G1/4, and so I bought G1/4 to 3/8 inch hose barbs. Anyway, that's all the stuff that it's going to take. It all fits in here. I've got a 2-scale plan, so I know where everything's going to go. But I wanted to talk a little bit about how I got here. 20 days ago, I didn't know TIG Torch coolers from squirt guns. But since that time, I've learned from just about every website on the internet that talks about TIG Torch coolers at all, both commercial and do-it-yourself. And there's a whole bunch of do-it-yourself designs that I will show you in a minute. That research is what allows me to put together something like this. And I'm a firm believer in researching, then planning, and then building, and then using instead of going backwards. The analogy I like to use is you can't get halfway to the moon and then decide, oh yeah, that's not going to work. And I don't like to do that on my own projects either. I like to just plan it, do it, and use it. So we're gonna talk a little bit more about that process as we go through the putting together of all this stuff. I dug some aluminum out of my stores. I need to make a bracket for this that allows it to tilt out for filling and tilt back in. And then I need to I'm going to cut a lot of this framework out. You can see I've already got it marked. And then put one single sheet of aluminum across here. And that's what my radiator and fan is going to be mounted to. Power cord will come in here. And I apologize for the noise. It's garbage day. And they're taking our garbage right this second. And there you go. Okay, I want to talk to y'all about research. 20 days ago, I started out knowing nearly nothing about TIG water coolers. But after 20 days of a few minutes here, a few minutes there, looking at every website, looking at every YouTube video, looking at all the pictures that I could find of the internals and the specs and whatnot, I know quite a bit about water coolers now. The graphic that's showing right now is of the companion water cooler that would typically go with my Lightning MTS 275. And it's a very well respected cooler. It's almost $600. It would be over $700 by the time I got it here. So that's what drove me to design my own. All the commercial coolers are pretty much the same inside. There's typically a radiator and a reservoir and a single motor that drives a pump and a fan. From studying the commercial coolers, they typically hold about 2 gallons of liquid. They typically have a pump in them that delivers about 1.2 to 1.5 gallons per minute. And they typically don't generate more than about 50 psi. This is a picture of a no-name water cooler that I found on the internet. They're about $250 and they're sold by several companies. It was an option that I considered for a while, but I did read a few people that liked them in the beginning, but then they started having trouble with them. They had a leak or whatever. So I dismissed that as a possibility for me. I found several hobbyists that merely put a aquarium pump inside of a 5-gallon bucket and then hooked it up to their TIG torch. And it does seem to work. The water in the bucket gets warm, and so it needs to be replaced occasionally, but it does work, and it is very inexpensive. This is a variant of that. This uses a diaphragm pump and the battery, but still no radiator, so the water warms up. The more you use it, the more it warms up. This cooler has a very popular motor and pump combination. The pump is called a Procom, and it seems that this is a pump combination and motor that comes out of Coca-Cola bottling machines or something like that. And it doesn't seem to cause any troubles. There again, this doesn't appear to have a radiator. This is a very ambitious project. It's got a welded up tank and a fan shroud, electronics in a box. I can't see what kind of pump's in it, but this is pretty typical of the higher end units that I saw. This is a very nice compact unit. It uses a gaming PC radiator and a pump that I don't recognize, and it's being volume tested here in this picture. This fellow worked really hard to create this cooler. It's made from that strap that's in the lower left hand side. You can see the reservoir is welded up from that strap, a whole bunch of little pieces. This unit is huge. It seems to have a switch for each one of the individual pieces. You can see the reservoir is welded up, and I don't know what kind of pump that is, but I was impressed by the workmanship and how big it is. The builder of this unit advises that it's for a 350 amp TIG torch. It's a very nice job. It's when you look at other pictures, you can tell that it's really big, but the fellow is clearly a craftsman. Here's that Procom pump again. This one also has a flow indicator and a pressure gauge and a bleed-off valve. These Procom pumps create a lot of pressure, and it is often bled off with a little needle valve back into the reservoir. This is an interesting and compact design. It has a Procom pump, 2 reservoirs, what looks like a automatic transmission cooler, and a big fan. And it's small enough to fit underneath a welder. Here is a project just getting started. Another Procom pump, what looks to be about a 1 gallon reservoir, and some sort of a fairly thick radiator. This is a compact design. Another Procom pump. It's got a pressure gauge, a large radiator, but only a single 5-inch fan, and it's sitting on top of a welded up reservoir. This unit has a huge radiator, a diaphragm pump, and a small reservoir. And it doesn't look like it has a cooling fan for the radiator. Here's another compact unit with a Procom pump, a pretty big radiator, a single fan, and it looks like the enclosure is either done or very nearly done. This is a fairly compact design, another Procom pump. It looks like the radiator is aluminum, however, so there's a mix of metals in that design. Here's a big reservoir, a big radiator, 1 fan, 1 pump, 1 pressure gauge. This is an interesting work in progress. It's contained in a toolbox. It's got a diaphragm pump, a very small reservoir, a small radiator, and a small fan, and a power supply. This fellow started with a window type air conditioner, and he's made an 8-part series out of it on YouTube. And to wrap this up, here's a picture of what is typically inside of a commercial cooler. There's about a 2-gallon reservoir. There's a single motor that drives a fan on one end and a pump on the other. And then the radiator, notice the copper tubing in the radiator is on the other end. That's typically the back. There's also a bypass circuit plumbing in this picture, and that's fairly typical of what is in a commercial cooler. So I showed you all this to bring a point home about research and then design by researching what is considered current art, you get to see the best and the worst of each design. And by picking out the best pieces and making sure you don't fall into any of the pitfalls of those designs, one should be able to make a cooler, in this case, that is better than anything that's currently manufactured or that anyone has done DIY. Because you've got access to all of their knowledge and all their learnings and all of their mistakes. So after reviewing all of those designs and countless more, here's what I've come up with for myself. I definitely wanted an enclosure. Material to make an enclosure right now is extremely expensive, so I needed to buy an enclosure that was already pretty close. I wanted to have a PC gaming fan and a diaphragm pump, and of course you need a reservoir of some sort. And it's so that my machine would run on 240 and 110, I put in a power supply and purchased all 12-volt components. The layout is shown here in this picture. It's to scale but without dimension, and so you can see that by staggering the power supply and the radiator and the pump, I get quite a bit of space, and then the reservoir goes all the way across and takes up about a full 1/2 of the available space. The drawings show a LED pilot light, a switch, pressure gauge, and of course the inlet and outlet connectors for the TIG torch. This second sheet of the plans shows the plumbing diagram. The bulkhead fittings provide a 3/8 inch hose barb, and a little piece of hose goes to the pump. By turning the pump 45 degrees, it fits in the container better. And then there's another piece of hose that goes up to the radiator. I put the inlet and outlet of the radiator on top so that it's easier to bleed the air out of it. And then the outlet of the radiator goes over to a T, which then converts me from 3/8 inch hose down to 5/16, which is required for the quick disconnect connectors. And so I just went ahead and ran 5/16 over to the pressure gauge. When the water comes back from the TIG torch, it goes through a conversion from 5/16 to 3/8, and then the 3/8 inch hose goes back into the container, and we have a closed loop. I've provided a small parts list, and the last page shows a diagram of the bracket that is going to hold the water container, the water reservoir. It'll be welded up from sheet aluminum. It allows me to tilt out the reservoir to fill it up and then tilt it back in, and it'll be a fun little welding project. If I haven't lost you by now, the rest of the video is about construction, which may be why you came here. And so let's get on with that. So the first thing we're going to do is to cut out this back and get it ready to mount the radiator. So here's my little portable jigsaw. Okay, time for the third coat of red paint on the radiator and fan bracket. I chose red because this portion could be warm. Not hot enough to burn you probably, but it could be 100 degrees or so. Okay, while we're waiting on the paint to dry on the radiator fan bracket, it's time to mount some of the items in the front panel. This LED almost fits in this hole in the front panel where the power switch was, so we'll drill that out, and the new power switch, toggle switch, goes below it. There's a gauge that goes in the middle which I don't have yet, and it should be here in a few days. And then the water out is blue because it's cold, and the water in is red because the water's warmer by now. Go over here on the left side. The only real constraint is that this jug sits in here about like this, and the plumbing for these two things need to go behind it, or so the hoses that come this way, I want to miss the jug, so that means they'll probably be mounted over here a little farther, which means I'll have to cut out a little bit of structure right over here. I have to keep that's what the front hooks on, but I'll be able to cut some structure out of there, and actually I think it's on this side. I'll have to cut a little structure out of this side so that I can mount these and have the hoses go right about there. Okay, that's it for the front, except there's a 2.5-inch diameter gauge goes right here. And I know from past experience that you don't just drill the hole based on the blurbage that they give you when you buy the gauge. You wait till it gets here. And so I'm going to wait to put that in. Other than that, the front end is done. Okay, this video is getting long, so I'm going to sign off here. The front panel is complete except for my pressure gauge. This panel comes off, as you've seen in the video, but here's where most of the work went today. I got my aluminum plate built for the back of the cooler. It's bolted on. The radiator and fans will attach here. I've got a little cutout for the power to come in on this side. And then I got the glass door on it for the video purposes. So I'm going to sign off and say thanks for watching. Goodbye from Idaho, and stand by for part 2. As usual, if you like or dislike my video, please select the appropriate button and let me know why. I really appreciate comments, and I will answer every one. If you're new to my videos, please select the subscribe and the notification bell to get more videos like this.